All right, so to graph the rational function, I don't do it in the order that it's listed. So I start with the domain. So how do we find domain? Do you remember?
So then the denominator equals 0?
It's where your denominator cannot equal 0, right? Because remember, you can't have 0 on the bottom of a fraction. So I'm going to come down here and work on it. So my domain is going to be, you said it's where the denominator cannot equal 0. So that means where x minus 2 times x plus 3 cannot equal 0. Set them individually, then not equal to 0. And so we know x cannot equal what numbers? Good. X cannot equal 2 and x cannot equal negative 3. So we're going to write it in interval notation. So it's going to start at negative infinity and it's going to go to what number?
Negative 3.
Good. And then from negative 3 it goes to
0.
2.
Wait.
Just a second.
Yeah, you're right.
Okay. And then from 2 it goes to infinity. Remember, the 0 is not in there. It's the denominator cannot equal 0. The 2 and the negative 3 are the numbers that would make it equal to 0. That's why it just cannot be them. If I plug in 0, it's okay. It's going to give me another number. All right, so that's our domain. And then from domain, we're going to go do our wholes. Well, our wholes are going to be our canceled factors in the denominator. Equal to 0. So basically, it's whatever factors we can cancel that were in the denominator. So instead of putting the not equal to like we did in domain, we would just put the equal to on it, okay? So you got to make sure everything's factored out to find your wholes. I can't factor the numerator. The denominator is already factored out. Does anything cancel? No, I don't have an x minus 2 on top and bottom. I don't have an x plus 3 on top and bottom. So, nothing cancels, so it's none. Now, don't write this, guys, but if we had like an x minus 2 up here, then it would cancel and we would have a hole, okay? But we will, no, you would actually put where it is, and we're going to see that in a little bit.
So if x equals, that was the case with x equals 2.
Yeah, it'd be at x equals 2, and we'd have to find our y value. But don't worry, we'll find a hole in a little bit on another one. All right, so after my holes, I go do my vertical asymptotes.
So the holes are canceled, or like anything canceled out.
Right.
And so if we had a hole, we would put like one hole,
No, we would write where it is.
or write what the thing.
We'd say it's an ordered pair, and it's going to be wherever x is this number, and then we'd plug it back in to find the y. We're going to do it. Don't worry about how to find the hole yet, okay? Right now, there's just no hole. We'll have one where there will be, and then we'll find it. All right, so your vertical asymptote is your uncanceled factors of the denominator. It's where they're equal to 0. So, do I have anything that doesn't cancel out in the denominator?
Yes.
Yeah, the x minus 2 doesn't cancel, and so we saw when we did domain, that gave us the 2, didn't it? So I have a vertical asymptote at x equals 2, and the x plus 3 didn't cancel, so I have a vertical asymptote then at x equals negative 3. Now guys, these are lines, okay? So I want them written as x equals, and they have to be written separately. You can't put x equals 2, comma, negative 3. So x equals 2, x equals negative 3. They're two separate lines, and since they're lines, they have to have the x equals in front of each of them. All right, then we're going to do our horizontal asymptotes. How do we find horizontal asymptotes? It's the highest degree. And so remember, I taught you the shortcut no. Or it's going to be y equals a over b if it was both. So look at this one. We want to know where is our highest degree. Well, what's the degree on top?
0.
Yeah, 0. There is no x, okay? So it'd be like x to the 0. There's none there, so its degree is 0. What about on bottom?
2.
Yeah, 2. because of the x squared. So you would take this x times this x to give you the x squared. Good. So where's the highest degree, top or bottom?
Bottom.
Bottom. And if it's on bottom, what does it tell us it's going to be? Yeah, that's what that O is for, right? In the no, because it tells us it's y equals 0.
How does the no thing work again? Can you draw it to like the side or something?
Yeah. All right. So if it's no, remember that means if it's the highest exponent or the highest degree is on top, it's none. If it's on bottom, it's just y equals 0. Top is none, bottom is y equals 0. And if it's both of them, that's why I put or y equals a over b. Remember, if it's both, they have the same degree, then you have to do as a ratio of their leading coefficients.
Say that last one.
If the degrees are the same on top and bottom, then it's going to be a ratio, so you can make a fraction using their leading coefficients. So like if it was 3x squared over 2x squared, then it would be y equals 3 over 2. Okay?
That's cool.
All right, now let's do our x-intercepts. How do you find your x-intercepts?
This would be the time which is
Oh.
Yeah, 0 for y. Now, don't write this, but just look. If I do 0 for y right here, then I'm going to have to multiply by that denominator to get rid of it, right? And when I multiply this side by the denominator, what am I going to get? 0. So a little shortcut for your x-intercepts, it's always going to end up being where your numerator is equal to 0, okay? Because your denominator is going to end up canceling out anyways. So if you remember when we first talked about domain several weeks ago, and I told you the denominator is the only thing that mattered, and y'all asked what about the numerator, and I said it has its own job, and we'll talk about it later. Well, here's its job. The numerator's job is to tell me the x-intercept. All right, so for my x-intercept, we said we're going to let the numerator equal 0. What's my numerator here?
2.
Just a 2. Now, can I solve for x?
No.
No, there is no x. Does 2 equal 0? No, so this means there is no x-intercept, okay? Normally you will have a variable and you will go ahead and solve for it, but on this one you don't. So your x-intercept is going to be none. And this is what, number 5?
It's none again, why?
Because 2 cannot equal 0. I don't have an x to solve for, so therefore it just means it doesn't cross the x-axis.
Okay.
All right. Normally you might have like 2x on top. In that case you could solve for x.
Okay.
But here we don't have anything to solve for x, so it's just none. All right, and finally, our y-intercept. How do you find the y-intercept?
like
Yeah, plug in x equals 0. So I'm going to come down to the bottom again. I'm going to do a little work here. So for the y-intercept, it's where x is 0. So y equals 2 over, plug in x is 0, so 0 minus 2 times 0 plus 3. Work that out. So we get 2 over negative 2 times 3. So 2 over negative 6, which reduces to negative 1/3. And so my y-intercept is at 0, negative 1/3. Alright, so we've answered everything there except range. And range is easiest to do once you graph it. So we're going to wait till after we graph it, and then we're going to come back and do range. Oh no, hold on, my screen just went blank. Alright, so now we're going to go ahead and graph what we have. Okay, so that's the next thing I do. So I'm just going to go through and graph all the pieces. My x-intercept, I don't have any, so don't graph anything. My y-intercept is 0, negative 1/3. So I'm going to, on the y-axis, I'm going to go down to negative 1/3, and I'm going to put a point there. I have vertical asymptotes at x equals 2. How do we graph an asymptote? Yeah, dashed line, right? And I have a vertical asymptote at x equals -3. I have a horizontal asymptote at y equals 0. And that's all I have to graph. Alright, so to be able to tell what's going on in our 3 parts that are on our graph there, we're going to create this number line. So down here at the bottom, I'm going to do a little number line. It's kind of crowded. I don't like that, but it is what it is right now. And I know it's got my infinities at the ends. And what I'm going to put on this number line are going to be my x-intercepts and my vertical asymptotes. That's always what I put on my number line. And what it is I'm creating test intervals. I've got to test certain places to be able to tell where my graph is going to be. So, I don't have any x-intercepts to put on this number line, but I do have vertical asymptotes at, what is that, -3 and 2. So I need to pick a number in the interval from -infinity to -3. And guys, don't go drastic because you're going to plug this into the equation and have to solve. So pick a number between -infinity and -3. -4, that's a good one. It's not, it's a whole number, but it's out of the, or it's an integer, but it's not like drastic. It's not like -1 million. All right, so let's plug -4 into our function for x. So we get 2 over -4 minus 2 times -4 plus 3. So 2 over -6 times -1. So 2 over 6, which is 1/3. And so I'm actually going to go and I'm going to plot that point. So -4 and 1/3 is right there. Now, what that tells me is that my graph is going to be in this section. And it's going to be shaped, so it's going to be in that top left section. It's going to be shaped according to my asymptotes. So, as I'm going to go to the left, I have to go towards that asymptote which is down below it, correct? So I'm going to go down to the left, but am I going to cross that horizontal asymptote? No. So down to the left, it's going to look like it's getting flat, but is it really? It's not really getting flat, okay? Because it's slowly inching its way to the horizontal asymptote, but it's not ever going to touch it at the end down there.
How do you know it's supposed to go that way, though? Or what told you it's supposed to go that way?
Because it can't hit the ice.
Well, the asymptotes kind of draw it towards it, okay? So as I go to the left, it's not going to be able to go up or anything like that. It can't cross it because I don't have an x-intercept, right? So it's going to have to just slowly go towards it. Now, as I go to the right out of that point, well, as I go to the right, I hit that kind of intersection of that asymptotes, right? So it's going to force me then to go up. So as I go towards the right there, that asymptote that's vertical is going to force me to go up. Now, it does appear that I'm going straight up. Am I really? No. Again, I'm getting closer and closer and closer to that asymptote, but I'll never, ever, ever cross it. So I got that part of my graph. We're okay with it? Kinda? All right. It's a start. It's our first one, so it's all right.
I'm not okay with it, but
We're going to roll. All right, so now I need a point in the next interval. So from -3 to 2, give me a next value.
2.
I could use -2, but there's a better one.
2.
0. One thing, 0 is easy to plug in and solve, right? Another thing is, didn't we already do that? Yes. We did it. It's called our y-intercept, isn't it?
Yes.
So when I plugged in 0, I got -1/3.
Yes.
That was worked over here, right? So, and we can already see we already have it plotted, but I'm going to go ahead and plot it again here so that it's in my red or pink, whatever color that is. Now, as I go to the left, I'm hugging this asymptote here. Is that vertical asymptote going to force me to go up or down? Why down? Why not up?
Because you already have one going up.
Well, not because I have one going up. Do I cross the x-axis anywhere in there? Do I have an x-intercept? So I can't go up, because to go up out of that point, guys, don't draw this, but if I went up, I would have to have an x-intercept there, wouldn't I? And I don't. So I'm going to have to go down. Am I going to cross that x-intercept? Am I going to cross that vertical asymptote? No, I'm just going to get really close to it. All right, same thing as I go to the right out of that same point, guys. I can't go up because, again, to go up, we have to have an x-intercept, and we don't. So it's just going to force me to go down. So it looks like a parabola, doesn't it? Kinda. Mine's a little chunky parabola. It's all right. We don't know for sure if it's chunky or if it wasn't. Just do our best on it. Yeah. All right, then we got the last section over there. So my last interval from 2 to infinity, I need to pick an x value.
3.
3. All right, so I'm going to come up above here and I'm going to work that out. So when I plug in 3,
Get 1/3
6. Yeah, 1/3. Again.
right, we get 1/3 again. That's okay. That means we know where it's at because we've already graphed it, right?
Yes.
So graph your ordered pair, 3 and 1/3. And can you visualize now seeing what this one looked like over here, how this one here is going to look like it? It's going to be kind of a reflection of the one on the left, isn't it? It's going to be shaped by those asymptotes. So as I go to the right, as I go to the left, it's going to force me to go up. And as I go to the right, I'm just going to have to hug that horizontal asymptote there. And there's our graph. Now, the only thing I didn't do is I haven't done the range yet. So look at that graph. What numbers do we know it cannot be?
0.
Can't be 0, right? So we know then our range, what is this number? Technically, I guess this is number 9.
Where's number 8?
Number 8 would have been our number line. I just didn't. Sorry about that. All right, and number 9, so you said it can be every number but 0, so -infinity to 0, and then 0 to infinity. So yeah, so we're going to watch out for our horizontal asymptotes. But remember, a horizontal asymptote, it can cross in the middle, right? So that might not be a restriction in our range. So watch out for horizontal asymptotes and watch out for holes. The holes could get us. All right, so there's our graph.